Okay, starting 5.5 trig, so trigonometric identities, or we call it trig identities. Okay, so this is something that's really new to you guys. There is no step-by-step process to answer each of the questions, but I've provided some kind of guidelines. Okay, so this is what happens is we get these equations, and what we want to do in each of these equations is prove that one side of the equation is equal to the other side of the equations. Okay, and we do so by simplifying one side or both. We cannot move things side to side. What we do is we work with one side and we try to make it equal the other side. Okay, and we do that by using these identities. Okay, so these first three here, we already know. We've already gone through them. So cosecant is 1 over sine, secant is 1 over cos, and cotangent is 1 over tan. Okay, so then we have a couple new ones here. So if you actually take sine and divide it by cos, you'll get tan. And if you divide cos divided by sine, you get cotangent. Okay, just give me 1 second. I want to turn the TV down. Okay, sorry about that. Okay, and then we have a couple identities here on the last one. You don't have to know the titles of these on a test that would be giving you all of these. Okay, so we have sine squared theta plus cos squared theta is equal to 1. These last two are very rare, but they do show up maybe once, maybe twice, but very rare. This one's very, very popular. This one is the most popular identity is here. Okay, then we have 1 plus tan squared theta is secant squared theta, and 1 plus cos squared theta is cosecant squared theta. I also want you to note that you could change these a little bit. Okay, so for instance, if I cancel out our sine squared theta and put it onto the right side, cos squared theta would be equal to 1 minus sine squared theta. Okay, and that would be the same if we bring cos over to the right side. Sine squared theta would equal 1 minus cos squared theta. Okay, so you could rearrange some of these identities. Okay, so here are the guidelines in order to answer these. Okay, so the idea is we want to make each side the same. So we want to make one equal to the other. Okay, so what we're going to do is simplify one side at a time, and we're going to start with the more complicated side, the one that's more complex. What we want to do is every time we see these cosecant, secant, cotangent, tan, we want to change them into sine or cos. Okay, so that's one. This is the key one here. So anytime we have these, we want to change them to sine or cos. And then what we're doing is simplifying algebraically. Okay, so let's go to the first one. So since we're proving, what I'm going to do is put a line down here through the equal sign, because we can't move things across the equal sign and we can't cancel them out. But what you want to do is make this left side equal to the right side. Okay, this lesson is very important for grade 12, because you do this again once you're in grade 12. And instead of dealing with these 8 here, you end up dealing with about 20 of them. Okay, so here. So we're going to simplify. This one's the more complicated side, so we're going to work with this. And then this is the third point. Any one of these 4 things, we want to convert them. So we have a tan theta here. So let's convert it. So looking at our identities, we have tan theta is equal to sine over cos. So we're going to switch tan into sine theta over cos theta and carry down the cos theta. Mind this is multiplication. Okay, and when we multiply here, these cos, since we're multiplying by cos and dividing by cos, they cross off, and you have your answer of sine theta. Okay, which equals our right side. Okay, so that is the first one. So we prove that this equals that. Okay, moving on to the next one. Let's see what we want to do here. So here's the more complex one. Trying to think what we'll do. Okay, so let's change the secant. So following our third step again. So secant is the same as 1 over cos. So we have 1 over cos theta times by 1 plus cos theta. Okay, then we're going to multiply these. So we'll distribute within the brackets. So 1 over cos theta times 1 is 1 over cos theta. And cos theta times 1 over cos theta is cos theta over cos theta. Okay, cos theta over cos theta equals 1. Okay, so we're almost there. We're almost there. It's very similar. That's now, since this one has a secant, so you have an option of turning this into cos, or we could just now switch this into secant. And they equal each other. Okay, so we proved that one equals the other. Okay, moving on to the third example. Okay, so working with the more complex side, which again is the left side. So we're going to convert the secant into 1 over cos. Okay, trying to think what to do next. Okay, so let's make a common denominator here. So we'll put this over 1. So since we're subtracting, so we want to have them both of the same denominator. So we're going to multiply this one by cos theta on the top and the bottom. Okay, so when we do that, we get 1 over cos theta minus cos. So cos theta times cos theta is cos squared theta all over tan theta. So I'm following the rules of converting. So I converted to cos. Now I'm simplifying algebraically. Okay, so bring these together. So I get 1 minus cos theta, cos squared theta over cos theta. I'm going to do, since I have a fraction over another number, I'm just going to change this division sign into the line into a division sign. So we have divided by 10. Okay, so this one here, 1 minus cos squared theta, goes along this identity here. So remember I said we could move the cos squared theta over. So if I did that, sine squared theta is equal to 1 minus cos squared theta. So 1 minus cos squared theta is equal to sine squared theta. So we're going to convert this into sine squared theta. Okay, and then we want to, again, part of the rule in step 3, convert this into sine and cos. So tan theta is equal to sine over cos. So we're dividing by sine theta over cos theta. It's getting blurry, okay. Okay, so now let's simplify this. We can't divide fractions, so we multiply by the reciprocal. So we're going to multiply by the reciprocal of this fraction. So we have sine squared theta over cos theta times, now the reciprocal, cos theta over sine theta. Okay, so again, we're trying to get to this sine theta. So now we could, since we're multiplying, we could cross off cos theta and cos theta. Okay, so sine squared theta means there's 2 of these, and we have 1 here, so we could cross off one of these with one of those. So we're just left with the single sine theta, which is equal to our right side. Okay, so some are very easy, and we move to more difficult ones. Okay, there is also multiple ways to answer these, so just because I did this one this way doesn't mean it can't be done another way. Same with this, just because I did it this way doesn't mean I can do it another way. Okay, and now moving on to our last question. Okay, so we'll start with the more complex side, which I'm not sure what that is, but I know 1 minus cos theta, or cos squared x, is the same as this. So it doesn't have to always be theta. It could be an x, it could be a beta, it could be any symbol here for the angle. In this case, we have x's. So 1 minus cos squared theta, or cos squared x, is equal to sine squared x. Okay, so I'm going to leave that side as it is, and now work with the right side. So again, step 3, convert anything into sine and cos. So I'm going to convert the tan. So cos squared x. Okay, so tan squared x. So you can still use this formula here, this identity. If it's a square, so we could do this for a square. So if this is squared, then we have a square for both of these. So tan squared x would also be a sine squared x over cos squared x. So tan x actually turns into sine squared x over cos squared x. Oh, my pencil just broke. Okay, and simplifying this right side, cos squared x crosses off, and we're just left with the sine squared x, which matches the left side. Okay, so that is the lesson for today. So homework, page 310, number 2, 4, 5, 7, and 8. This section is not necessarily the favorite section for many students. Personally, I really like them because they look, for me, they're like little puzzles. So if you just follow the guidelines, you should be able to get through the identities. But obviously, there will be some difficult ones, or there'll be ones where you might not think of a certain method. So the more you do, the better you will get at them. And obviously, we can take up any questions when we have homework time. Okay, so page 310, 2, 4, 5, 7, and 8. Take care. Bye.